We'll proceed in pseudo multivariate calculus. Okay, so long discussion on the pseudo multivariate calculus, non-ending. We'll try to finish with this volume. Then we will take some examples that will include the kind of differential equation. Solving a problem. The concept is not boasting about the calculus, how great it is. Solving a problem. I have to solve a problem and it may involve calculus and vector. It may not involve calculus and vector. It may involve algebra. It may not involve algebra. What is the idea? Idea is to solve a problem. That's it. That is the idea. That is the idea. Okay, now pseudo multivariate calculus means while solving a problem, then we come to know that we have to use calculus, we have to use vector. But how we come to know that we have to use calculus for sure? For that we have discussion called pseudo multivariate calculus, where all of a sudden we will come to know that we have to use calculus indeed, and how we can convert our problem solution, whatever solution we are making, at the middle only turning into calculus. Oh, sorry, I should have started this with calculus. Why I started this with algebra? That is the wrong thing I did. No, whatever the person is, the way he is trying to solve the problem and he is in mid of the problem, and then suddenly he feels that it is looks like it is not solvable and I should have started with the calculus, then at the middle only how I can transform my solution into calculus, vector, whatsoever. That is pseudo multivariate calculus we are talking. And in that phase, we are trying to come up with something called area vector. An area vector has two paths to proceed upon anyway. In book, there is only one path that we have devised, and that is called pseudo multivariate calculus. Through pseudo multivariate calculus also, we can calculate the area vector. If I have area vector, with area vector, if I do dot product with the velocity vector, I get the flux. If I calculate the magnitude of the area vector, then I get the net area, whatever I want. Area vector, it is in vector. If I calculate magnitude there only, then I get area, net area. Or if I do dot product with the velocity vector of the area vector, I get the flux. Okay, that is the concept of area vector. How to come to area vector? Through pseudo multivariate calculus we have seen. Through pseudo multivariate calculus, we have seen that area vector is either I plus dz by dx bracket close cross product with bracket j plus dz by dy bracket close dx dy, or rather I plus dz by dx bracket close dx cross product with I j plus dz by dy bracket close dy, or rather xi plus yj plus zk cross product with xi plus yj plus zk. Simple. Cross product of two length vector give the area vector. Area vector indeed is calculated by the two vector only. If I have this area, then this vector a vector and b vector cross product of these two gives the area vector. If I talk about the curved surface, then still this line a vector become a curved line and b vector also become a curved line. A vector can represent a curved line also. Generally, vector represent a straight line. If I say flat line, if this is a vector and this is b vector, then a vector I can represent it as xi plus yj plus z. This is pseudo multivariate calculus. I'm trying to find the area vector of a curve. Okay, like a sphere curve. Anyway, for the flat a vector, b vector, a vector in 3D can be written as xi plus yj plus zk. B vector in 3D can be again written as xi plus yj plus zk. Cross product of these two will give the area vector, that is xi plus yj plus zk. Cross product xi plus yj plus zk. Now this one, if I consider this if I transform this xi plus yj plus zk, that is considered as a straight line vector, to curve line, then to get the curve line vector, I have to take out x or y. From one I'll take out x and from other I'll take out y, because I had considered pseudo means we take the simplest case. We consider this is x axis and this is y axis. So one side I'll take out x and other side y I'll take out. If I do so, then straight line vector will become vector representation of a curved line. Then it will represent the curve area. This is how step by step we proceed in the pseudo multivariate calculus. One will become I plus y by xj plus z by xk bracket close into x cross product with xyyi plus j plus z by yk bracket close into y. Division will become differentiation and multiplication will become multiplication integral calculus. Then it will become I plus dy by dx j plus dz by dx k dx cross product with dx by dy I plus j plus dz by dy k bracket close into dy. These two lines, if we see carefully, one line I had taken curve line like this and another curve like this. If these two curve line I replace in a sphere, if I if I take a sphere, then any point P I take, consider this a sphere is centered at the origin. If this sphere is centered at the origin, from the origin I draw a vector, it will cross through P. If I draw a vector that will cross through P, then at P I make a x in xz plane I make a cut, in yz plane I make a cut. If I cut this sphere in xz plane and yz plane, it will resolve into a circular line in xz plane and circular line in yz plane. In xz plane, circular line is a curved line, and in yz plane, circular line is a curved line. Now I'll re-represent what we have written. That is I plus dy by dxj plus dz by dxk bracket closed into dx. If this is in xz plane, then dy by dx is 0. Another is dx by dyi plus j plus dz by dyk bracket close into dy. If this is in yz plane, then dx by dy is 0. In that case, it becomes I plus dz by dxk bracket close cross product j plus dz by dyk bracket close into dx dy. This is the area vector we received through the pseudo multivariate calculus. If I talk about Cartesian coordinate, then one is xi plus yj plus zk, another is xi plus yj plus zk. X is r sine phi cos theta I as per spherical coordinate system plus r sine phi sine theta j plus r cos phi k 1 cross product with another is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. One is b vector, one is a vector. Now, if I talk about the way I cut in xz plane and yz plane, the way I did, and in that way, whatever we did, then we took out x. So now we took out x from one side, we took out y from one side. If it is a spherical coordinate system, then r is constant. If we talk about the sphere surface, then r is constant everywhere. If r is constant, then theta and phi are variable. Let's take out theta from one side and phi from other side. Then one side will become r sine phi d cos theta by d theta I plus r sine phi d sine theta by d theta j plus r cos phi by d theta, that is 0. Cross product with r d sine phi by d phi I am taking out. First become I have taken out theta. So first become r sine phi d cos theta by d theta I divided by theta plus r sine phi d sine theta by d theta j plus r cos phi by d theta k, that is 0. Bracket close into d theta, because d theta I have taken out. That's why I am dividing by d theta. Cross product with r d sine phi by d phi cos theta I plus r d sine phi by d phi sine theta j plus r d cos phi by d phi k. Since I have taken out phi multiplied by d phi, if someone settle it down, it becomes r sine phi minus sine theta I plus r sine phi cos theta j cross product with r cos phi cos theta I plus r cos phi sine theta j plus r minus sine phi k. bracket close into d phi, d theta d phi. This is area vector in Cartesian coordinate system. Now we will try our luck through the traditional way, whatever written in the book. In book it is written that area vector is nothing but derivative of position vector. If I take a surface position vector, position vector can be surface position vector. A position can be volume position vector. A position vector can be length position vector. If I have a curved line, this is origin, and this is a curved line. If I take any point P here from origin, if I connect through a position vector, this point P, this position vector is called position vector for a point on a curved line. If I take any point P here, that is x comma y comma z from center, if I draw a position vector, that position vector would represent a position vector on the surface area. Anyway, if I do d of position vector, if position vector belongs to a curved line, then it will be line vector. Position vector is position vector from origin to point on the line. But if I differentiate it, it will become a line vector. Similarly, if I have a position vector belongs to a surface area, d of position vector will be give the surface vector. So in the modern calculus, like if I'm trying to calculate the flux, then velocity vector dot product d of position vector is the net flux, but d of position vector is the area vector, derivative of position vector. Anyway, let's concentrate on derivative of position vector. Position vector is xi plus yj plus zk. Derivative is dxi plus dyj plus dzk. This is area vector, but this is a pseudo code, abstract code. This is not the real one. To get the real one, I have dp. I divide dp by dxy and then multiply by dxy. dp by dxy plane into dxy plane. On the xy plane, now there are two surfaces. One is xy plane. On top of it, I have a shape. On xy plane, I have so many x comma y. For every x comma y, I have function over x comma y, and that is the height, and it go and hit a point on the surface z and x comma y. That point is x comma y comma z. Okay, that point is x comma y comma z. Now there are two surfaces. One surface is xy plane and another surface is this surface. Now the dp by dxy plane, if I move 1 unit of area, dp by dx, if I move 1 unit of length, dx, along x-axis, how many unit change I see in position vector? Similarly, dp by dxy plane is, if I move 1 unit of area, it is dxy plane, not dx. If I move 1 unit of area on xy plane, then how many of unit area, if x comma y point on xy plane go and map to point P here, then from P, how many unit of area change I see? If there is 1 unit of area change I see on xy plane, dp by dxy plane. In that sense, we took delta x, delta y area on the xy plane, and then we try to see how much area change that happens there, that is dp by dxy plane, and it came as dp by dx cross dp by dy into dxy plane, that is delta x delta y, dx dy. This is the area vector, dp by dx cross dp by dy into dx dy. This is area vector in the from the dp approach. Let's try again. We are talking about this is Cartesian coordinate. We are talking about a spherical coordinate system. How it will come in a spherical coordinate system? To get in a spherical coordinate system, now we have d of p. P is position vector, and position vector is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k dp. Let's do dp by d theta phi, because theta phi are variable in a spherical coordinate system as far as sphere surface is concerned. Radius is constant everywhere on the surface of a sphere. I'm not talking about volume. In that sense, dp by d theta r into dp, d of area position vector is the actual area vector, but this is abstract only. D of P is same as D of P by D of theta r into, I'm sorry, D of theta phi into D of theta phi, because theta and phi are variable. If that is the case, then d of p by d theta phi into d theta phi. In theta phi plane, if I make one unit of change, then how much I see in the position vector? That is under question mark. Anyway, let's consider position vector is in x, y, z only. Makes sense? It is in x, y, z only. If that is the case, then now there are two planes. One is called theta phi plane and one is xy plane. These are independent components, means they are varying. Okay, z is dependent component. Okay, I'll I'm trying something. I'm trying dp by d theta phi into d theta phi. dp is the actual area vector, but that is pseudo code. dp by, earlier we did dp by dxy plane. If this is p, then this is xy plane. One unit of area change in xy plane brings how many unit of area change in p? Okay, dp by d theta phi into d theta phi, where p, right now I consider p as xi plus yj plus zk only for time being. Okay, now we have two things now, two area now. One is theta phi plane and one is xy plane. dp by d theta phi. If I make one unit of change in theta phi, one unit of area change in theta phi, how many unit of change, area change I see in p, whatever it is. Now we have two kind of plane. One plane is theta phi plane and one plane is xy plane. Okay, I'm not talking about the surface area, just xy plane. Earlier we had xy plane, on top of it I had surface area. Now we have xy plane and we have theta r. xy are xy and z, whatever it is, xy and z. Let's talk about x and y. xy are function over theta r phi. xy are function over theta r phi. Okay, in that sense, xy is function over theta r phi. X equal to r sine phi cos theta. R is constant here. So x equal to r sine phi cos theta. X is function over theta and phi. R is constant. That's why I have taken only x and xy and theta phi. R is constant. X is a function over theta and phi. X equal to r sine phi cos theta. Y is function over theta and phi. Y equal to r sine phi sine theta. If that is the case, now if I have on theta phi plane, consider there is a point called theta comma phi. There is a point called theta comma phi here. Similarly, here in xy plane there will be a point here called g theta comma phi, h theta comma phi. Make sense? G is a function over theta comma phi, that is x. Means I have a point here on xy plane called x comma y. This point is exactly mapped from another point called theta comma phi. How you are mapping this? Because I have taken a function x equal to r sine phi cos theta, means x is a function over theta and phi. Let's consider x equal to g theta comma phi. G is a function over theta comma phi, because x equal to r sine phi cos theta. In that case, if I have a theta comma phi, correspondingly, I will have x comma y, because x is function over theta comma phi, that is g theta comma phi. Y is function over theta comma phi, h theta comma phi. Now I am trying to find dp by d theta comma phi. dp by d theta comma phi. I believe it is all right. dp by d theta comma phi. Okay, if that is the case, dp by d theta comma phi. If that is the case, then if I take here theta comma phi, I have a point here x comma y. That is g theta comma phi comma h theta comma phi. From here, I move along theta and another point is theta plus delta theta comma phi. This is P, then this is one point theta comma phi, then another point is theta plus delta theta comma phi. From here I'll go up. This is this is Cartesian coordinate system. Means this is theta and phi angle are 90 degrees to each other, similar to x and y. If point is theta comma phi, from here I go along theta and another point is theta plus delta theta comma phi. From here I go here and another point is theta comma phi plus delta phi. Similarly, if I map this, then this point is x comma y. Then similarly, it will not go straight because there is a mapping, right? It will go to some other point. If this is P, consider temporarily P, then another point will be G. If this is G theta comma phi, S theta comma phi, another point will be G theta plus delta theta comma phi, H theta plus delta theta comma phi. Similarly, here the other point will be G theta comma phi delta plus delta phi, comma H theta comma phi plus delta phi. Now, if I'm trying to see that if there is a area change, if there is a area, how much area change I am seeing. If there is a point called theta comma phi here, and then I move along here, that is theta plus delta theta comma phi, and I move in this direction, theta comma phi plus delta phi, then we are discussing about area change of delta phi delta theta. In that sense, here there are two lines we are tracing out. One line is from g theta comma phi comma h theta comma phi to g theta plus delta theta comma phi comma h theta plus delta theta comma phi, and another line that is going is g theta comma phi plus delta phi comma h theta comma phi plus delta phi. So here if I make delta theta delta phi area change, then here to get the area change, this vector and this vector I have to do the cross product, then I'll get the area. They may not be rectangle, maybe some parallelogram or some other shape. In that sense, what is this vector and this vector? This vector, if I talk about, then this will be g theta plus delta theta comma phi, g theta plus delta theta comma phi minus g theta comma phi, comma h theta plus delta theta phi minus h theta comma phi. This is this vector, and this vector will be g theta comma phi plus delta phi minus g theta comma phi, comma h theta comma phi plus delta phi minus h theta comma phi. Okay, now this if I do cross product of these two, this is the area change because of delta theta delta phi. We are talking about dp by dp is in xyz. I have taken only 2 dimensions. Okay, someone can convert into 3 dimensions. No one is stopping anyone. If that is the case, then z is the 3 dimension. Z is also a function of theta and phi. Z equal to r cos phi. For simplicity, I have taken 2 dimension only. In that sense, dp by d theta phi into d theta phi, dp by d theta phi, d theta phi, change in theta phi is delta theta delta phi. For that, I see change there as p1p minus p2p, p1p minus p2p. P1p is g theta plus delta theta comma phi minus g theta comma, g theta plus delta theta comma phi minus g theta comma phi. Okay, comma h theta plus delta theta comma phi minus h theta comma phi. Cross product. One is I should complete it. G theta plus delta theta comma phi minus g theta comma phi I vector plus h theta comma delta theta plus delta theta comma phi minus h theta comma phi j. Whatever comes, cross product with g theta comma phi plus delta phi minus g theta comma phi, comma h theta comma, this is I, plus h theta comma phi plus delta phi minus h theta comma phi j. Okay, divided by delta phi. Delta theta I can keep this side and delta phi I can keep that side. Now someone can introduce third function also, gh and alpha. Alpha is another function for the z. Then anyway, let's do with that dual function only. Now it first one becomes g theta plus delta theta minus g theta comma phi I plus h theta comma delta theta plus delta theta comma phi minus h theta comma phi by delta theta. This is exact case of d of g I plus gi plus hj by d theta. What is dg theta? I'm sorry, d differentiation d of g theta phi by d theta. D of a function g theta phi by d theta, that is g theta plus delta theta comma phi minus g theta comma phi by delta theta. Here we have g theta plus delta theta comma phi minus g theta comma phi I vector plus h theta comma delta theta plus delta theta comma phi minus h theta comma phi minus h theta comma phi j. Okay, whole divided by delta theta. It is as good as d of gi, d of gi by d theta, I vector. I'm sorry, d of g function, g theta phi function by d theta, I vector plus d of h d theta by d theta j vector. G of theta phi is x. That is dx by d theta, dx by d theta I plus dy by d theta j, or it is d of xi plus yj by d theta. Makes sense? I have not taken z into account. If I add z here also, it will become d of xi plus yj plus zk by d theta. Cross product. Now I have to settle down another one. Another one is g theta comma phi plus delta phi minus g theta comma phi I. Cross product g h theta comma phi plus delta phi minus h theta comma phi j. Okay, I'm sorry, I'll reiterate. So the first what we saw, that is d of xi plus yj plus zk by d theta cross product. Another is g theta plus phi plus delta phi minus g theta comma phi I vector plus h theta comma phi plus delta phi minus h theta comma phi j vector. Okay, plus alpha if I take z also, divided by delta phi. It will be exactly as dg by d phi I plus dg by d phi j plus dh by d phi j plus d alpha by d phi k. Considering alpha is a function for z equal to alpha theta r phi, theta phi. In that case, the second one becomes d of xi plus yj plus zk by d phi. It becomes d of xi plus yj plus zk by d theta cross d of xi plus yj plus zk by d phi. So d of p, once in the previous video we tried d of p previous to previous. D of p is d of p by dxy plane into dxy plane. That came as dp by dx cross dp by dy. Now I have taken d of p by d theta phi into d theta phi. That came as d of dp of d theta cross dp of dp by d phi into d theta delta phi, d theta d phi. Now I can settle it down. What is p? P is xi plus yj plus zk, or r sin phi cos theta I plus r sin phi sin theta j plus r cos phi k by d theta. Cross product d of r sin theta cos phi r sin phi cos theta I plus r sin phi sin theta j plus r cos phi k by d phi. Okay, where r sin phi cos theta is x, Cartesian coordinate, spherical coordinate. conversion. Now, in that sense, first become r sine phi minus sine theta I plus sine theta I plus r sine phi cos theta j, another is 0. Cross product with r sine r cos phi cos theta I plus r cos phi sine theta j plus r minus sine phi k. This is exactly same what we got through our pseudo multivariate calculus. Means it proves that our pseudo multivariate calculus, the way we started fundamental, that if I have to calculate the surface area vector of a curve, let's take a simplest, that is a rectangle, and then one vector cross another vector, and this vector is xi plus yj plus zk, this vector is xi plus yj plus zk. Then for curve, this vector will turn into vector representation of a curve line. And forget the vector representation of a curve line. The vector representation should have y by x. Please watch our previous video. Should have y by x or x by y. So a vector I transform into I plus y by x j plus z by x k into x, and b vector I transform into I x by I plus j plus z by y k into y. Then I transform division into differentiation and multiplication into integral calculus, and then we came to same. So there, here I took out x and I took out y. In a spherical coordinate system, here I took out theta and took out phi and did the cross product. It exactly come as same thing. Means through the our pseudo multivariate calculus, cross product of two curve vector, that one vector curve line cross vector representation of two curve line, or two length vector, one length vector in xz plane and one length vector in yz plane. Okay, in that way, if I do cross product of these two, then I get the surface area vector. Length vector through pseudo multivariate calculus, we know how to calculate. If I cut any sphere in xz plane, yz plane, I get two length vector. One is in xz plane and one is yz plane. In xz plane, whatever we get, we take out theta, so that it will become representation of a curve vector. And there I take out phi, and it becomes exactly same as dp by d theta cross dp by d phi into d theta d phi. But this the pseudo multivariate calculus, what we are talking, the approach what we are taking, whenever we see problem, go with the simplest case and start progressing from there, and then later convert the multiplication into integral calculus and division in. This has innumerous possibility, innumerous power, because this way we can solve many differential equation also. Anyway, we will see more on it. Probably one more session is required. Then we will see tough examples again through the pseudo multivariate calculus. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.